Now, this idea is going to get more complicated as we look at more complicated solids. So here's another one of these problems. Find the volume of the solid obtained by rotating the region bounded by the function y equals x cubed, y equals 8, and x equals 0 about the y-axis. Okay, so we're still rotating. We're still expecting circles as the cross-section. But this is the picture that I've got. Again, in blue, I've got my region set up. Y is equal to x cubed. But if I'm rotating this around the y-axis, I get, again, sort of a solid parabola, some kind of solid cone. I'm having some difficulty saying the word parabola today. But if I want to find my area function, slicing in the x direction is going to give me different solid parabolas, right? Can you imagine that? If I sliced on x, I would see different parabolas. Maybe at x equals 0, it's a parabola that touches the x-axis. For different values of x, I'll get a parabola that doesn't touch the x-axis. That's going to be kind of complicated to set up an integral form. Instead, we can slice up the y-axis, right? And I have this nice circle here. I'll need to calculate its area function, but I know that my slices will have a width of delta y. Here we're saying that the radius should be, well, it should be the x-coordinate of my blue curve. And if y equals x cubed, then x equals the cube root of y. Well, that tells me about everything I need to know for this problem. Again, it might be a little bit uncomfortable integrating with the variable y, but this is something that we need to get used to. It makes problems like this so much easier to solve when I'm flexible about what is my independent variable, what is my dependent variable. So let's set up this integral. I'm looking at the region from y equals 0 to y equals 8. My area function is, well, my area function is pi r squared. What's my radius? My radius is the x-coordinate, and my x-coordinate is equal to the cube root of y. So my area function today is pi times y to the power 2/3. My thick cylinder slices have a volume of my area, pi, y to the 2/3 times delta y. And in the limit of the Riemann sums, I'm going to be integrating this function. So my volume is equal to the integral from 0 to 8, pi y to the 2/3 dy. Now everything looks good so far because the variable of my integrand matches the variable of my differential. So I can use my fundamental theorem of calculus, and I find that this solid has a volume of 96 pi divided by 5.